to just kind of go through and do quick introductions. So I'm just going to read down the list of participants here. And if you could just say your name and what county or agency you're with, that would be great. So first of all, I'm Annie Sakarik. I'm a natural resources planner with the Critical Area Commission. Next on the list here, we have a phone number that ends in 33. You want to introduce yourself?
Yeah, hi, my name's Brian Wilkins. I'm with Wicomico County Public Works.
Great, welcome. Next on the list is Aaron H.
Hi, this is Aaron Harding. I'm with Cecil County Planning and Zoning.
Great. Alex?
Good morning. This is Alex DeWeese with the Critical Area Commission.
Amber?
Hi, this is Amber Thompson, Permits Manager for St. Mary's County.
Cassie?
Hi, I'm the Environmental Planner for Wicomico County.
Charlotte?
Hi, Charlotte Sharon, Regional Chief with the Critical Area Commission.
Leah?
Hi, I'm Leah Langford with St. Mary's County.
Marilyn?
Hi, I'm Marilyn Williams, Land Development Coordinator for Wicomico County.
Mark?
Good morning. My name is Mark Carper with Kent County Planning.
Mike?
Good morning. I'm Mike Rassman with the Critical Area Commission.
Nick?
Nick Kelly, Regional Manager, Critical Area Commission.
Somerset County is on here. Who else?
Hi, I'm John Redden. I'm County Engineer for Somerset.
Charlie Sager, GIS Tech, and Catherine Skeeter, Planner.
Awesome. Thanks all. Stacy?
Hi, I'm Stacy Clements, St. Mary's County.
Susan?
Hi, this is Susan McClure, Critical Area Commission.
Valerie?
Hi, this is Valerie Caswell with St. Mary's County.
And I think someone just joined. Brian? Can you do a quick intro? And I probably should have said this at the beginning, but your mute buttons and camera buttons and hand raising buttons are down in the middle of the screen at the bottom. If you have any trouble muting or unmuting, that's where to find that. But anyhow, I believe that's the full list here. So welcome everybody again. Thank you so much for joining us today. In addition to those Google Meet features I just described at the middle bottom of your screen, there's also the chat button on the bottom right-hand side. So feel free to throw in any questions or comments throughout the presentation. Like the last training, we kind of want to make this as interactive as possible. So feel free to chime in with questions at any moment, even interrupt us if you don't understand something or need clarification. That's totally fine. So with that, here's an overview of our training today. There will be 3 sessions with a break after the first 2 sessions. First, we're going to provide a quick introduction to critical area stormwater management, as well as a brief review of MDE stormwater requirements. Then we're going to take a look at the Critical Area Stormwater Guidance Manual, including design and review guidance for various best management practices, or BMPs. And then in the third session, we're going to run through some demonstrations of the web soil survey and the 10% spreadsheet. But just a heads up, we were trying to mess around with the web soil survey earlier today, and it seems to be, the website seems to be down. So hopefully, fingers crossed, that the website will be working again by the time we get to it. But we may have to wing it with that one. But we'll let you know. All right, so now we're going to jump into the first session, which is an introduction to critical area stormwater management. And really quickly first, we're going to take a quick look at MDE's stormwater management requirements, also known as environmental site design to the maximum extent practicable, or ESD to the MEP. And even though MDE's requirements are separate from ours, we wanted to briefly touch base on them because critical area stormwater management was designed to be consistent with them. So here we go. I'm just going to go into MDE's website here. So this is their stormwater management webpage. And I just wanted to point out a few things. So like just scrolling down here. Maryland's first stormwater management law was passed in 1982 and mainly focused on controlling flooding associated with new development. The prescribed structural BMPs that were designed back then to trap, they were designed primarily to trap large amounts of runoff in a central area. However, over the years, it was determined that incorporating multiple smaller scale practices was more effective. The Stormwater Management Act of 2007 established environmental site design to the maximum extent practicable, again, ESD to the MEP, to require the use of small controls to mimic natural hydrology and limit the use of structural practices. In here, you'll see links to MDE's regulations, as well as link to their stormwater design manual. So there's some really good resources here on their webpage. So now jumping back here, I'm gonna go back into full screen. All right, there we go. So now we're gonna take a closer look at the specifically critical areas stormwater management requirement, which is also known as the 10% rule. So if MDE has separate requirements, why is additional stormwater analysis even required in the critical area? One of the reasons is that despite several decades of stormwater management regulation, stormwater is the fastest growing nutrient source in the Bay watershed. Also, research has conclusively demonstrated that both the amount of development within a watershed and its proximity to an estuary or wetlands contributes to the condition of the benthic fish and bird communities. Therefore, critical area regulations require additional analysis in order to minimize adverse impacts to water quality from runoff. So in the critical area, post-development water quality is required to be 10% better than it was prior to development. Phosphorus is the keystone pollutant used to quantify stormwater management because it's representative of overall water quality. It's also one of the easiest elements to measure for water quality because it chemically binds to sediment. Again, this 10% pollutant reduction requirement is separate from MDE's ESD requirements. MDE's requirements are triggered by 5,000 square feet of disturbance anywhere, whereas the critical area requirements are triggered by 250 square feet of disturbance in the IDA. However, critical area stormwater is required in all critical area designations for state projects specifically. And I won't read through this full slide, but we just wanted to share this timeline with you to point out a couple of things. The first is that stormwater management has been a requirement in the critical area since the adoption of local programs in the mid-80s. The second important thing to note is that we have addressed this requirement, or how we have addressed this requirement has evolved over time. That's something to keep in mind moving forward because there will likely be more changes to the critical area stormwater requirements and guidelines as climate change continues to have an impact on our landscapes and weather patterns. So in terms of the interface between MDE and critical area requirements, there are times when one or both standards must be met. For example, as we've mentioned, critical area stormwater is required for projects in the IDA under 5,000 square feet, even though MDE stormwater is not triggered yet. When both are required, the best management practices, or BMPs, should be designed to meet MDE's ESD requirements. If the phosphorus load removed from the ESD practice is greater than the 10% pollutant reduction requirement, then the 10% rule has been met. Otherwise, additional or alternative practices may be needed or may need to be implemented. And then just to keep in mind, BMPs should be part of the overall design of a project, not just an afterthought. It can be really difficult to incorporate stormwater management to meet 10% after a project is completely designed. And then also make sure that the 10% spreadsheet is filled out and submitted for any project where critical area stormwater is required, even if the removal requirement is met with ESD, because it just kind of serves as verification that the critical area requirement has indeed been met. And we'll get into more detail about that spreadsheet in a bit. So in addition to the overall 10% pollutant reduction requirement, there's an additional requirement for redevelopment. MDE has specific requirements in COMAR for redevelopment called Impervious Area Requiring Treatment, or IART. It basically specifies a 50% reduction in impervious surface below existing conditions. Because it's typically impractical to actually remove 50% of existing impervious, environmental site design practices, or ESD to the MEP, can be used to meet the equivalent in water quality control of a 50% decrease in impervious surface. This redevelopment requirement provides a way to address existing untreated impervious area. And so, to be consistent with MDE, the critical area also has a redevelopment requirement, but it's related to phosphorus removal, not impervious surface. So the 10% spreadsheet, which again, I'll get into more detail in the next slide, automatically calculates the average annual pre-development load based on whether the project is new development or a redevelopment site. Redevelopment rules apply if the existing site is more than 40% impervious cover. The phosphorus removal requirement for redevelopment sites is to reduce the pre-development phosphorus load by 50%. But again, this is automatically calculated when you enter the information into the spreadsheet. So now to kind of touch base on our 10% spreadsheet, which you all are probably somewhat familiar with, but it is available on our website. And we're going to review the spreadsheet in more detail in one of the later sessions today. But this is just going to provide just a really quick, brief overview of what the spreadsheet looks like and how to fill it out. So again, this is our Critical Area Commission website. This is our Stormwater Management page, and then we have various tabs here. I'm going to just click on the IDA 10% Stormwater Management spreadsheet, and it's going to slowly load. So here we are, and let me see if I can zoom in a smidge. So again, this is our spreadsheet, the 10% pollutant reduction spreadsheet, and the blue cells are the cells that you input information. So that's what you fill out. The gray cells are automatically populated with formulas. And then down here, you'll notice that there's various tabs. So the second tab down here is a summary tab that just provides a quick snapshot to see if the reduction requirement has been met. And then there are these various other tabs down here for the different types of best management practices or BMPs that you may be considering using on a site or that you're using on the site, and you have to insert those specifications for that specific BMP. This spreadsheet enables designers to find the most cost-effective combination of ESD practices that comply with ESD and 10%, this critical area 10% requirement. And it adjusts the effectiveness of proposed ESD practices based on the individual BMP specifications. So that was just a really quick overview of it. But again, we're going to get into more detail and go through some examples later on today. All right. And so as an alternative to on-site or off-site BMPs, some jurisdictions have a fee in lieu program for stormwater management. The current fee in lieu rate is $35,000 per pound of phosphorus. The Critical Area Guidance Manual has a different amount, but that's from 2011, and MDE has since updated that value to be $35,000 per pound. And you have to set up a program to manage, track, and implement fee in lieu, and that account has to be separate from any other fee in lieu accounts that you may have in the county. And then also the Critical Area Stormwater Management Manual on our website has guidance for the use of planting offsets, but we'll get into more detail again about that and the guidance manual itself in the next session. So that is it for just a quick, very large overview of critical area stormwater management and MDE's ESD requirements. Are there any questions before we move on to the next session?
And just FYI, if anyone doesn't want to unmute and ask their question, feel free to just type it into the chat. We're going to be monitoring that throughout the presentation. So we're happy to answer questions that way as well.
I have a question. So, we can only apply regulations here on the county level. So if we have conflicting regulations between MDE and the critical areas, is it the stricter of the two apply?
When are you thinking there would be conflict?
I don't know that there is, but if there were, I mean, are there any conflicts that you know of between the two? Since you're regulating things differently. You're regulating phosphorus, whereas MDE is regulating impervious, that type of difference.
Yeah, so typically what we see is usually what stormwater management you might be required to provide for MDE requirements. Often that does meet our requirement as well. If one requirement is met but the other is not, you would have to provide additional stormwater management to meet whichever requirement is higher. So I would say it's less like a conflict and more you are kind of having to provide stormwater management to the highest requirement, whether it's MDEs or ours. Does that make sense?
Yes.
Okay. Are there any other questions? Okay.
All right, you can take it away, Mike.
Okay, thanks, Annie. Appreciate it. Great job. And I will follow up to the best of my ability on some of the stuff that Annie brought up in session 1. Bear with me on the technical side of things as we transfer ownership of the presentation. All right, so can everyone see session 2, Critical Area Stormwater Guidance Manual?
Yep, we see it.
Looks good.
Okay, great. Thanks. So good morning, everyone. I'm Mike Grassman, another natural resource planner with the Critical Area Commission. And today I'm going to talk a little bit about the Critical Area Stormwater Guidance Manual. Again, this is just kind of a broad overview of the guidance manual and some of the BMPs that are mentioned in that. For more in-depth questions or information, feel free to reach out to us and we can talk offline about it. Now comes the tricky part. All right, there we go. Okay, so the Critical Area Stormwater Guidance Manual, there is consistency with MDE's guidance. The Stormwater Guidance Manual conforms to statewide methods and equations that are prescribed for environmental site design to the maximum extent practicable compliance. Has the same nomenclature and practice names as outlined in the statewide manual. Provides for phosphorus removal rates for the list of environmental site design practices, which is in Appendix A. And it provides level 1 and 2 phosphorus removal rates for a few of the structural practices. I'm going to attempt to show you where this is located on our website. All right, so far so good. So this is our website, which you'll find in Critical Area. Once you get onto the landing page, you'll see on the left-hand side, there are a number of different categories you can click on. Go to Stormwater Management, just like you did earlier when Annie was showing you how to access the spreadsheet. And then if you wanted to look at the IDA 10% Stormwater Manual, it'd be at the top of this column right here. And here we go. Environmental site design criteria for Maryland's critical area. I'm not going to go through this in great detail, but I'll just go over quickly what you're going to find in this manual. So we have an introduction, talks about the critical area and the buffer, evolution of stormwater management practices in the critical area, why this edition was created, and some of the differences between this and the 2011 edition. As we get into part 2, a lot of the frequently asked questions on basic stormwater management design and policies will be addressed in part 2. Moving into part 3, we go into the spreadsheet tool, which Annie covered in the previous session. And part 4 talks a bit more about the actual BMPs and some of the practices and specifics that you're going to find on different BMPs in the critical area. Then part 5, as mentioned, goes into offsets and different offsite compliance that you can apply for stormwater management in the critical area. And references cited, the appendix that summarizes some of the phosphate removal rates for the critical area, and different documentations are Appendix A and B. And as we mentioned earlier, if there are any questions at all as we go through this, especially as I start touching on some of the BMPs, we encourage interaction in this. So feel free to jump in on the chat or just raise your hand or just cut me off if I'm rambling. Can we consider that guidance final? And Aaron had a question.
Yes. So the 2003 guidance was our original stormwater management guidance manual, which was approved by the commission. The 2011 version, which is on our website, was never officially brought back to the commission for approval. However, it was updated basically to reflect MDEs when they changed to environmental site design requirements. So the 2011 version is the best one to use because it reflects the requirements currently under MDEs. Chapter 5, their ESD chapter. Does that answer your question, Aaron? Yes, I believe so. The 2011 would be, yeah. Aaron asked if there was any conflict between the 2003 and the 2011. We should refer to the 2011 one. That would be correct, yes.
Right.
Sure.
Cool.
Yep.
Great question. Good question. So briefly touch on level 1 and level 2 designs. As mentioned on the slide, the design level approach for estimating phosphate or phosphorus removal capacity of certain stormwater management practices. Level 1 achieves lower phosphate removal, and level 2 has more stringent design capacity. We're just touching on this. This is generally something that planners will not come across, but it is mentioned in the stormwater manual. So it's something that we wanted to just touch upon. And again, level 1 design equates to MDE's minimum design standards and criteria for environmental site design practices, while a level 2 design has a much more enhanced list of design features, which will maximize phosphorus removal. But once again, typically, we won't see a level 1, level 2 design differentiation in a lot of the plans that come into our office for review. So our stormwater cheat sheet. Now, this is completely separate than the stormwater guidance manual. And I believe, did this go out in the earlier email to everybody? Did we get that out, or are we going to send it out after this?
Nope, it was included in Susan's email with the attachments. Okay. Yep.
Excellent. So if people have this available, you're welcome to follow along, since there is a lot of information on this. And it is a very handy resource that Charlotte put together. I am not going to go into a huge amount of detail on all of this because, again, it is very comprehensive, but it is a great resource if you're reviewing some plans. It is important to note that we are not stormwater engineers, right? This is one of the reasons why we have something like this. Basically, if something comes like this into our office, this document will allow us to better review the BMPs in order to ensure they meet the specific requirements, because some of these BMPs do have very specific criteria in order for them to be effective and achieve what they're designed to do. So when going over some of these, it's important to look at this reference or this resource and make sure that the BMPs that are being proposed are going to meet the specifications. So one thing you'll find that's common in most of these, there's a few criteria that'll be listed under each practice. You'll have environment or location, soil types that it's best used for, the construction specifications, things that it is recommended for, and definitely things to be aware of or that it is not recommended for. And those are typically highlighted in red or in italics when you're going through this. I'm not going to really talk about the simple rooftop disconnect or the non-rooftop disconnects right now, because we'll go into that in a little bit more detail later on in this presentation. So we'll start with some sheet flow conservation area. Again, so it's highlighted here in the location information that Tidal and non-tidal wetlands themselves should not be included in the calculation of the 20 square foot area and the 50-foot width requirements that are listed in the construction specs because lack of infiltration. Really important to pay attention to some of these specifications because it does talk about depth between filter strips, fact that this cannot represent more than 25% of the treatment area for required volume, recommended for restored soils. So if it's not in the right soil type, this should not be applied. There's a filter strip that should be part of the construction specs with a gravel diaphragm, infiltration berm. So there's a lot that needs to go into this. Each one of these BMPs also has a very handy dandy graphic to help further explain what it is best used for and how it's best applied. Sheet flow to a conservation area is typically something you'll see in a slightly more industrial area where you'll have a large parking lot or whatnot, and you have a slope where this is going to run off into your effective area, and you must have certain buffer widths that maintain in order to make this effective. And again, I encourage everybody to jump in, and if you have questions about some of these as I'm going through them, or if you see a lot of these come in to your respective jurisdictions and you want to follow up or add more on it, please do not hesitate to jump in. Reforestation or soil restoration. So something to note is that this is not used for credit under Forest Conservation Act or for any kind of critical area clearing mitigation, buffer mitigation requirements, buffer establishment. This is specific to a stormwater management practice. It is not to be used in conjunction with mitigation. And you have to be very specific about the slopes that are going to be used in it, the soils that are going to be used in it. There are criteria for the long-term restoration and reforestation that has to be monitored. There's invasive monitoring, density of the stems that have to be planted. So if somebody is going to propose this practice, it is very important to make sure that you're looking at these construction specs and making sure that they're meeting all of the monitoring, care, replacement easements that would go along with reforestation for stormwater management practice. Going to skip to permeable pavers because that is something that we do see quite often come in, or we suggest that sometimes as a best management practice when people are having some difficulties achieving stormwater management on site. It's very good for driveways, patios, sidewalks, and whatnot if people can afford to put them in. You have to be careful about what soils you're going to put them in, what the water table is for the area where they're going to be established. And it's important to look at the ratio of the external contributing drainage to the area of permeable pavers that are to be put in. It cannot exceed a 2-to-1 ratio in here. And also one of the cautions that lists on here is that you can't have more than 10,000 continuous square feet of permeable pavers when you're putting this in. And you should be aware that some clever or some contractors may attempt to be clever by separating the 10,000 continuous square feet of pavers with a few non-pervious pavers or pavement in there. Examples of pervious pavers are listed. Moving on to rainwater harvesting. You're typically to see this in residential areas, maybe some like commercial projects. I've just actually got to see one where it's a larger cistern that wasn't typical, but what we typically see. But usually we'll see something like this picture right here. I actually have something like this on my home too, to capture a little bit of the runoff and use for gardening and whatnot. So really easy practice to put in, but you just have to make sure that there are a few specs which will be maintained when you're putting in a rain barrel as a stormwater management practice. Skipping over submerged gravel wetlands because this is another one I'm going to go into a little bit more detail in future slides. All right, all over the place here. Landscape infiltration, again, something that's recommended for small residential or smaller commercial projects, has to have highly permeable soils to be effective. And one of the important things to consider here are the different media and the different layers you're going to have in order to make this an effective BMP in terms of surface bonding, soil media, gravel, sand, etc. So if you do have a plan like this come across your desk, please take some particular notes about this. You also have to have a certain amount of runoff or minimum distance between where the home is going to be and where the landscape infiltration area is going to be. Moving on to micro infiltration and dry wells, another small residential commercial project area. Be aware of the contributing drainage area because it has to be less than about 500 square feet. Should be some pre-treatment that goes along with it, either through gutters or like a grass filter strip. Have some media installed as a reservoir. We have a good graphic here with your rooftop runoff and the splash block that goes into it. We're always a big fan of rain gardens. It's a great environmental site design practice to put in. I think one of the things that's kind of important to highlight on this is that, one of the things that's really important to highlight about the rain gardens is there needs to be information conveyed about this, especially if the property changes hands. You know, the coordinates of the rain garden should be recorded. There should be some kind of covenant or right of way that goes along with it, because if this is a stormwater management practice that goes along with a property or a residence, we want to make sure that if that property does change hands, the rain garden isn't just going to be removed because people don't like it or they you know just don't want to have it in there. So it's not just an aesthetic feature; it is an actual BMP that needs to be kept and maintained.
Do people really, I mean, are other municipalities, are they really doing a deed restriction on a rain garden?
I mean, there are various ways to handle it, you know, including maintenance and, you know, maintenance requirements on plats and things like that. But there, you know, inspections related to stormwater management, I know are difficult. Jurisdictions don't necessarily have the manpower to you know go out and look at every single rain garden that was put in for a development project. But you know, having at least notes on the plat related to what's required, you know, of the stormwater devices on site is at least one way to address it. And it looks like Aaron Harding from Cecil added in the chat that inspection and maintenance agreement is required for the stormwater management ordinance, and inspections are required by the MS4 permit.
Right, but that's under stormwater management guidelines. So, but you don't have anything separate as far as a model stormwater. I mean, we can use the same stormwater management agreement with MDE, but if we have a case where, so you don't have a model to use.
We do not. Yeah, if you have a case where critical area stormwater is required, but MDE stormwater is not, you know, I think you could use this similar plat notes and similar language to what's used for MDE requirements. Aaron said that in Cecil, they would typically wrap it into the stormwater management plan review.
Cool. Thank you for the questions and the
yeah. Thank you for jumping in with questions. That's great.
And thanks, Aaron, for sharing that information too with everybody else, because it is important. And it's as Charlotte noted, with any of these, it can be, you know, the monitoring and maintenance with all of these BMPs is a huge factor to their effectiveness, and it can be difficult to make sure that all of these are being inspected, especially if you're there's just a lot of them going on, and as time goes on, more of them are going to be put in. So just touching briefly on some microbiome retentions, I think the important thing to highlight on this is in the construction specs, looking at the percentage of the filter media that's going to be on here for it to be effective. And also that, I'm not sure if everyone is aware of it, but having like a landscape plan attached to this microbiome retention that includes some vegetation, shrubs or whatnot, that's going to cover a certain percentage, and that those, you're going to select the correct plant species that can make this an effective BMP. Going up to a regular bioretention, you're looking at just a larger area that's going to be treated, and pre-treatment cells have to have like grass strip, stone diaphragm, and other approved pre-treatment structures that are going to be in here. I'm just going to go quickly over the grass channels and swales. These are other BMPs we often see. A grass channel is you're going to see it along a road, low density development projects. This should not be used for any kind of parking lot or rooftop. You have to have permeable soils in here. Paying attention to the slope on all these is very important to make it an effective BMP. Maximum contributing drainage area, flow velocities. So it's a little more complicated than just kind of digging a ditch and hoping that this is going to be effective for your BMP. Once again, as shown earlier in some BMPs, this can only represent no more than 25% of the treatment area required for the treatment volume. As we get into bioswales and dry swales versus wet swales, it's just some of the major differences, of course, are looking at the environments that these are going to be used in. For bio dry swale, very similar to grass swales, having filter media incorporated into it is one of the main differences in here. But again, you have to look at the ponding depth, maximum flow depth, slope that is going to be put into, comparing the length of the channel in terms of the contributing impervious cover that it's supposed to be treating, and having setbacks from residential areas. And here we have a good example of where a bioswale can be used and how you have stone reservoir underneath it and different media. Main difference for your wet swale is going to be that it's much higher water table. Again, a non-residential area, and you have to pay a lot more attention about your surface draining area and flow velocities through different storm events. The last few BMPs that are covered in this cheat sheet are more conventional stormwater practices. Sand filters, you're going to see this in just kind of a contamination hotspot, brownfields, redevelopment sites in much more urban areas that have groundwater contamination risks. The wet ponds and the wet ED ponds, we do not typically recommend them for practice in the critical area. And then your shallow constructed wetlands as a conventional stormwater practice or something where you're going to see them in areas where water table is much, much closer to the surface, and being aware of different construction specs for those. I know it's a lot to cover very briefly, but hopefully you all be able to utilize this resource if you have any questions. And if you need more follow-up on that, feel free to contact your planner. We wanted to highlight rooftop and non-rooftop disconnects in a bit more detail because it's a common practice that we see, and sometimes it's not applied as efficiently as it can be. And Aaron has a comment in here. Can't remember a situation where stormwater practice had to be installed for ID requirements that didn't also trigger stormwater review under MS4 permits.
Sorry about that, Mike. I missed it.
Nope.
The sound didn't go off. Okay, so Aaron said, to be fair, I can't remember a situation when a stormwater management practice had to be installed for IDA requirements that didn't also trigger stormwater management review under our MS4 permit. Yeah, so he's going back to the conversation with Merlin and just saying that, you know, what he's thinking about are the cases where both MDE and critical area stormwater management requirements are both required as opposed to just critical area, not MDE. Thank you, Aaron, for adding that.
So again, just to touch on a couple of BMPs in a bit more detail, since we do see them frequently. Rooftop disconnection involves directing the flow from the rooftop downspouts into vegetated areas where it can soak into filter or the ground. The disconnect from the rooftop, so the disconnect from the sewer or storm drain system reduces the runoff and pollutants that are delivered into receiving waters. Maintenance of areas receiving the disconnection runoff is generally no different than what would be required for basic lawn or landscape care. The areas that receive the runoff should be protected from future compaction and development of impervious, including but not limited to swimming pools, patios, other structures that would change the flow path of the site and the drainage. In commercial areas where there's foot traffic, foot traffic in these areas should be discouraged where the flow is going. I've seen some examples of rooftop disconnects, especially recently, where like 5 different rooftop disconnects were all kind of dumping into the same discharge point, which was an area of steep slopes and highly erodible soils. And while it may not have been the primary factor that contributed to a pretty massive slope failure, it definitely was not helping the situation. So I think it is important if we can see a plan in advance and in our comments kind of, think outside the box. And if we saw a situation like that where there are sensitive environmental features and we have multiple rooftop disconnects that are all kind of funneling into the same point, it's something to be aware of and include that in our comments, because it won't really achieve what the applicant is hoping for. It's also important to look at this this buffer you have down here, 75-foot max on here, before you're getting into a water discharge area. There we go.
I have a quick question. I think that the MDE requirements allow for 60 feet on the eastern shore. Is there any allowance for that in your regs?
Yeah, that's interesting. Charlotte, do you?
Yeah, we would follow MDE's recommendations for that. They do often have different Eastern Shore, Western Shore spec design requirements. So yeah, we would follow MDE's guidance on that.
Is that typically because of just like soil infiltration or whatnot?
Yeah, it's usually related to the soils or the water table. Yeah.
Okay. Looking quickly at some non-rooftop disconnection. Disconnected non-rooftop areas involve directing flow from the impervious surface, such as a large driveway, street, sidewalk, into a vegetated area where it can soak into a filter or over the ground. In this example, we have a parking lot where there is a transition strip into a sloped area that will then help to absorb the water with some vegetation and different media.
Hey, this is John Redden. I've got a question for you. Well, a comment first. The non-rooftop and rooftop disconnect we use all the time. That's right. Very standard. Somerset County, the houses are, I'll just say, average houses, not mansions, with tennis courts and pools and large impervious areas. So that works out great. But anyway, my question is, a certified professional have to prepare these plans to be submitted, like an engineer or a surveyor? Does it have to be sealed or anything like that?
So we do not have a requirement for that in our regulations. I do not know if MDE does. I'm not as familiar with their requirements related to that. And I think it also differs by local jurisdictions. So it may be required by some counties and not others.
Right.
But that I can look into that more if there's anything in MDE's regulations. If you'd like us to do that, I'm happy to do that. Oh, Aaron is saying that MDE does. So Aaron, thank you. Aaron knows the answer. Yeah, apparently MDE does require it. But like I said, we do not have that requirement. But that doesn't preclude a local jurisdiction from requiring it.
Right.
Yep. Good point. Yep. We normally do with stormwater. But I was just kind of thinking on the kind of the micro scale that we're talking about today, an individual house level or a small project that doesn't quite make as much sense as a large one. Yep.
Yeah. And I mean, with MDE, they're like, if given that they require it, it might make more sense because they're looking at disturbance over 5,000 square feet. So they would be looking at larger projects than perhaps what we're talking about today. So yeah.
Okay. Thanks.
Thank you. Thank you for the question and the comment.
Cool. Excellent. Yes. Thank you very much. Just looking at submerged gravel wetlands, because this is another one that we see frequently in this design. The runoff flows through the rock filter and wetland plants at the surface. The pollutants are removed through biological activity on the surface of the rocks, as well as by pollutant uptake by the plants. The practice is fundamentally different than some other wetland designs because while most wetland designs behave like ponds with differences in grading and landscaping, the submerged gravel wetland actually will take care of some of the pollutants through aerobic and anaerobic activity. So that's one of the biggest things to be. It's kind of like a mini wastewater treatment plant in here. So making sure that all the various layers and filter media are meeting the specs is very important to ensure that this is going to be a functional BMP. And this is what it would look like in practice. Any other questions on some of the BMPs that we went over? I didn't want to go crazy with all of it. I know I spent some time on stuff, but before we move on to the last portion of this, is there any more comments or questions on various stormwater BMPs that we touched on? Okay. So to talk about stormwater and critical area buffer zones, that is one of the HPAs we are most concerned with. In general, stormwater practices are not permitted in the buffer. There are some exceptions in terms of buffer management areas. If you have a planted BMP and it's kept out of your setback, whether it be a 25 or 50-foot setback, as long as that practice is outside of that, then it could be allowed. Stormwater pipes and outfalls are allowed to cross the buffer, but they must discharge into open water. And it must be at least 1 foot above the mean low water line to account for extreme tides and future sea level rise. The buffer cannot be used for disconnection purposes, rooftop, non-rooftop, sheet flow to conservation area. Again, there is an exception for this. It meets a minimum distance. 75-foot distance between the closest impervious surface to the landward edge of the 100-foot buffer.
Or 60 feet on the eastern shore, I guess.
Yeah, good call. Thanks, Charlotte. Should definitely update our notes on that. It may be permissible to construct what is known as a regenerative conveyance wetland, also known as a coastal plain outfall within the buffer, if there is an existing erosion problem or other sensitive habitat features around the stormwater outfall within a stream or a valley. Aaron's question was about MBAs for.
He said, does that also apply to modified buffer areas?
For which practice? For the
disconnection purposes. I believe so. Yes, it would. BMPs within the buffer. So yeah, what Mike was saying earlier is that if you have a BMA area, you can put
Right.
certain types of BMPs within the buffer as long as they meet the setback requirements
Just have to be
for
outside
the
the setback.
BMA. Yeah,
So this is Aaron again. It might be just easier if I ask the question.
sure.
So in Cecil County, we have long linear lots, and most of the time that, or in some cases, there's a house that's in the modified buffer area that's closer than would typically be allowed. But installing a best management practice uphill is not practical.
Yeah.
Is if it triggers a stormwater management requirement. How are you saying that BMP cannot be placed in the buffer in those situations, and that pretty much eliminates any type of development that would have been allowed in that modified buffer area?
So in the modified buffer area, you can put a BMP within the buffer as long as it meets the setback for the modified buffer areas. So it's usually 25 feet or 50 feet from mean high water. And we would be looking at BMPs that are like planted, so like rain gardens, microbial retentions, submerged gravel wetlands, depending on the water table and soils. And does that answer your question, Aaron?
Yes, I think.
Okay.
Yeah. Thank you.
Okay.
All right. Excellent. I'm glad we've had so much discussion about this. As was mentioned quickly in Annie's earlier presentation, there is the option for planting to meet the 10% pollution reduction requirement. This is something that we often encourage if you have a smaller project or if you have some space constraints. There's a formula. It requires a little bit of algebra. It's not really that tough though. So you have 1 acre of native trees, which equals 400 3/4 inch caliper trees. And that essentially will equate to 2.5 pounds of phosphorus removed. Or to simplify it a bit, 100 square feet of permanent disturbance can be offset by planting 1 3/4 inch caliper native tree. This is only applicable for small residential projects where you have 2,000 square feet or less of disturbance. Again, if there's a larger commercial project or something like that, we can't really advocate to have tons and tons of trees, but this is a really easy way for smaller residential projects to accomplish their 10% pollution reduction requirement by planting. In a brief example, 10% requirement is 0.35 pounds of phosphorus per year. This equals 56 native trees. Essentially, you're going to multiply your 10% requirement by 400, then divide it by 2.5 to get the number of trees required. I know I've worked with, when I was doing some work with Brian Leitner recently in Charlestown. This was a way to satisfy some of their requirements for projects up there. So always something that we, as long as it meets that requirement for a smaller project, is something that we usually will turn to help satisfy the BMP. So thank you all. I appreciate your attention and the comments and questions on everything. And now we have a bathroom break or coffee break or whatever you would like before we get into the demos. Thanks,
Awesome.
everyone.
Thank you, guys. I think our break is about 10 minutes. Is that right, Susan, on the agenda?
Yes, we have 10 minutes scheduled. So should we all, I guess, come back at about 5 after 11:05?
That's perfect. Yep.
Sounds
That's
good.
fantastic. Thank you.
Thank you. So hello, everyone, again. I think we're going to get started with session 3 of critical area training. And in this session, we're going to discuss soil types, and then we were planning to do a demonstration of how to use the web soil survey to identify soil types and print soil reports. However, the last time I checked, the application was down. So when we get to that portion of the session, we will do our best to explain how you can use that application, or fingers crossed, maybe it will be up by then. So I'm going to pull up the presentation. Is everyone seeing the presentation now on their screens?
Yeah, it looks like it's in your notes mode though.
Okay, let me see if I can pull that. Let me stop sharing and see if I can. Is it still in notes mode?
Oh, that looks good.
Looks good.
Nope,
Okay.
now it's full screen. That's
Okay,
perfect.
Perfect. All right, so soils are classified by the Natural Resource Conservation Service, or NRCS, into 4 hydrologic soil groups based on the soil's runoff potential. The 4 hydrologic soil groups are A, B, C, and D. A soils generally have the smallest runoff potential, and D soils the greatest. So why are we discussing hydrologic soil groups during stormwater management training? Because soil properties, including the hydrologic soil group, govern which stormwater management practices are feasible at a given site. The hydrologic soil group also influences the phosphorus removal rate that stormwater management BMPs can achieve. So during the previous session with Mike, you saw that the design specifications for various types of stormwater management BMPs included references to the HSG soil type. Generally speaking, BMPs that rely on infiltration to provide pollutant reduction, and this includes microbioretention, sheet flow to conservation area, and permeable pavements, function at a higher level when located in soils with high infiltration rates, and these are the A-B type soils. Conversely, BMPs that rely on maintaining a continuously saturated layer to provide water quality treatment, such as the submerged gravel wetlands that Mike spoke about in the previous presentation, function better when located in soils that have lower infiltration rates, and these are the C-D type soils. So this slide includes brief descriptions of the 4 hydrologic soil groups. So group A is sand, loamy sand, or sandy loam types of soils. It has low runoff potential and high infiltration rates, even when thoroughly wetted. Group B soils are the silt loams or loams, and they have moderate infiltration rates. So as noted earlier, the AB soils are the soil types that promote infiltration, and these are the sandy or loamy types of soils. With group C, we begin to see clay-type particles in the soil. So group C soils are the sandy clay loams. They have low infiltration rates when thoroughly wetted. And group D soils are the clay loam, silty clay loam, sandy clay, silty clay, or clay. And this HSG group has the highest runoff potential and a very low infiltration rate. So since the CD soils have low or very low infiltration rates, if infiltration type BMPs are proposed in CD type soils, the pollutant removal rate is typically lower, and or an underdrain must be included in the design. In addition, some BMPs are not recommended at all in CD type soils. So the Web Soil Survey provides soil data and information produced by the National Cooperative Soil Survey, which is operated by the NRCS. NRCS has soil maps and data available online for more than 95% of the nation's counties and anticipates having 100% in the near future. We were planning to demonstrate how to use the web soil survey to find information regarding soil types for a specific area of interest. However, as I stated earlier, actually, let's go back. So we can navigate to the web soil survey homepage, and this is what it looks like when you go there. And I'm going to try one more time to navigate to the application, but as I stated earlier, it isn't working. So I think what we can do is just describe what you would do if you went to the web soil survey. And there are various tabs located at the top of the page. And the first tab that you would use is the Area of Interest tab. On the Area of Interest tab, you would define your area of interest. So you could draw a rectangle or a polygon, and which would include your area of interest for where you're trying to find soil data for. We were planning, again, to use the area of interest that Alex will be speaking about in her next presentation. But again, since we can't access the site, I guess we can't do that at this point. So the next tab at the top of the page would be a soil map tab. And so you could click on that tab and it would show you detailed information for all of the various soil types that you actually have in your area of interest. So if you draw an area of interest, you might have 2, 3, 4, 5, 6 different soil types, and then that tab would give you detailed information. And for our purposes, the most important information we'd be looking for is the hydrologic soil group. So you would scroll down on that particular screen that popped up, and it would show you which hydrologic soil group that particular soil type consisted of, whether it's A, B, C, or D. And that would be helpful information for your stormwater management BMPs. And then if you went back to the top of the page and you scrolled over to the shopping cart tab, and you could get a custom printable report for your particular area of interest. So this report would include general information regarding soil surveys, how they're done, the limitations on using them, the different types of soils. It would also contain a custom soil map for your area of interest. So that report would include every single soil type that was in your area of interest, and it would give you detailed information on that soil type. And again, the hydrologic soil group being of particular interest for stormwater management. So I apologize for not being able to do that today. We had a great demonstration plan, but I guess it's just, just a reminder that things don't always go as planned. So having said that, we did, think ahead a little bit, because I now want to share an alternative method for identifying soil types using Merlin. So Merlin is a DNR online mapping application that includes various GIS layers related to natural resources. Merlin in the screen, so if you can, I hope you can see the screenshot on your slide right now. The SURGO soils layer is checked, and SURGO is an acronym for Soil Survey Geographic Database. The SURGO data is the same data that's found in the Web Soil Survey, which, as we stated earlier, is produced by the Natural Resources Conservation Service. So I clicked on one of the mapped soil polygons, and this is shown in blue on the screenshot. And again, this is the same area that Alex will be discussing when she goes over a site plan review in the next session. I turned on the attribute table, and I did this by clicking on the 3 small dots to the right of the SURGO soils layer, and I clicked on View an Attribute Table, which you can see at the bottom of that list, the second from the bottom. I then scrolled over to the right. First I found the highlighted map unit symbol, and in this case, we were looking at the AUB soils, and that's what's shown highlighted on your screen right now. So I found that particular map unit symbol, and then I scrolled over to the right until you could see the hydrologic soil group column. And you can see that this particular soil group is mapped C. So to summarize, the Web Soil Survey and SURGO Soils GIS layer can be used for general planning purposes. It is important to note that soil mapping is not an exact science, and hydrologic soil groups should be field verified prior to installing stormwater management BMPs. This can be accomplished by soil test pits, soil borings, and soil infiltration tests. And this is especially important for infiltration type BMPs that require specific infiltration rates to function as designed. So thank you for your attention during this overview of soil types. And I'll now, I guess if anyone has any questions before we turn it over to Alex DeWeese for a demonstration on how to review a site plan to ensure compliance with critical area stormwater management requirements. So if anyone has any questions regarding soil types, or if you've used the web soil survey in the past, maybe, and have any questions or comments about using it, or any questions at all about, infiltration rates and how they affect various types of BMPs.
I've got a question. I know with the stormwater management side of things, when we have infiltration practices, we have the soil borings, like you said, and we require that from a geotech. Is it required for the critical area purposes to have a geotech perform the infiltration rates and everything?
Yeah, so we would defer to the MDE stormwater manual as far as like different best management practice, like specs and design criteria. So if there are practices that MDE is going to require that for, it should be done in the critical area just the same way. Our 10% requirement is, it works well in conjunction with MDE's requirements in some ways, and then it also is not as specific as MDE's requirements, I guess, is the best way to put it. Because, the 10%, Annie touched on this in her presentation, our 10% requirement was written into our law, in the mid 80s when our law was passed. And so what MDE's stormwater is now, it was not that in 86. So as MDE's stormwater has morphed and changed, our 10% requirement, because it's in our law, that requirement has stayed the same, but how we've, attempted to meet it has changed with MDE. So there's a lot of deference to MDE's requirements, I think, currently with the way our 10% requirement works. So we're really relying on MDE a lot when it comes to like the best management practice design specifications. So no, we do not have like a specific geotech requirement written into our regulations, but if it's a BMP where MDE would require that, we would, it should be done the same way, really. Does that answer your question?
Yeah, that's fine. Thanks.
Okay.
And then to follow up on that a little bit, MDE does have a number of technical memos that gives additional guidance, and technical memo number 7 does give guidance on exactly that topic on, the types of soil investigations that should be done for the various types of BMP. So if you wanted to check that out, that would give you a little more detailed information.
All right, thanks guys. This is Alex. I'm going to go over the 10% spreadsheet and we're going to do a little demo. Apologies in advance if there's some coughing or sneezing on my end. I am sick. Or if you hear like a long awkward pause, that's probably me trying not to sneeze. So sorry about that, but we will get through it. So we're going to go over the Bemby Beach example, which is in Anne Arundel County. This was maybe, I don't know, 5 to 7 years or so ago. I believe Susan sent out material for this for you guys to look at in advance if you wanted to. So there should be both a completed 10% worksheet as well as stormwater management design plans and site plans. Additionally, if you wanted to, you could go ahead and download a blank 10% spreadsheet from our webpage and follow along and kind of input things as we discuss them. Also, just to reiterate before I kind of dive in here, please feel free, as usual, to jump in with any questions, especially if you're trying to follow along in the spreadsheet and input that info yourself. Like, I certainly don't want you to get behind. So if you need me to take a step back or go into more detail, please let me know. I'm happy to do that. And I'm going to try to go through this somewhat slowly because it is pretty detail specific. So yeah, we'll just get into it. Okay, so I'm going to show you a site plan for this one in a minute, but just some generics for the site that are definitely applicable to the 10% spreadsheet itself. The site area is 5.28 acres. And so when we're doing the 10% spreadsheet, sometimes your site area might be way bigger than your actual limit of disturbance, in which case we'd encourage you to use just the limit of disturbance. For example, if this site area were 10 acres, but the work was only being done within 5.5 acres, we would just be paying attention to that 5.5 acres. The existing impervious on site is about 1/4 of an acre, and they are planning to keep that. I will point out this area in a second. And then new impervious is 1.84 acres. The soil type, which you would have seen if the web soil survey had been up today, it's entirely type C soil. So I think that's a sandy, loamy clay, if I remember correctly. Okay, so if you are following along or you checked out the materials we sent beforehand, this is from the site plan sheet 1 of 10. This is our overall site and stormwater management plan. So I had mentioned before that the existing impervious on site was about 1/4 of an acre. It's just this road through here. And that we'd be adding 1.84 acres. So it's all of these townhouses. I'm not sure how many there are exactly. Excuse me. But it also includes that 1.84 acres of new proposed impervious surface also does include these permeable pavers. And permeable pavers have been highlighted on this plan in this dark gray color. And so while they do count towards the impervious coverage, they are also at the same time treating the stormwater management that's required for these projects. So some other things to note about this particular site plan is that anything in this horizontal stripe kind of feature is forest conservation area. We also have a wide variety of stormwater best management practices. So I've already mentioned there are lots of permeable pavers throughout the site. But we also have several microbiome retention facilities, rain gardens. So there's rain garden here, a filtera system, and then rain garden planters pops up several times, especially kind of like at the back of each of these townhouses. They're very similar to rain gardens. It's just that they aren't planted in the ground. They are kind of a container rain garden. So again, similar, but not exactly the same. And we also have a submerged gravel wetland. Now, because we have so many practices and limited time, and all of these, again, are pretty detail specific, we're not going to talk about every single one of them. But if at the end you do have questions, we can go over that. But we're going to kind of try and focus on 1 or 2 practices for now. So in our 10% spreadsheet, and I'm going to go into this live a little bit later, but it was just easier for the time being to just do screenshots. The first page is just site detail information. And step 1 on there is complete ESD implementation checklist. So Annie had mentioned earlier that areas that are highlighted in blue are input areas. Everything else, we just leave it alone. It either auto-populates or it's telling us something. So this one, I've actually left blank. So did the applicant. This was intentional. I personally don't usually use this or input this information, but I wanted to mention it because you'll obviously notice it when you're in the spreadsheet. This is more of just a checklist for when you're reviewing or for the applicant who's completing this document to check and make sure that these things have been considered. So also on this page, we have step 2, which is calculating site imperviousness and water quality volume. Again, we're only inputting information in the blue boxes. So for site area, as we discussed earlier on the first slide, excuse me, It's 5.28 acres. And again, we say site area, but this could also just be the LOD. The existing impervious surface, which was that road going through the neighborhood, is 0.28 acres. And then proposed impervious, this is something that we see people get wrong a lot. And I think it's not exactly intuitive here. Proposed impervious, you might think, okay, well, what's the new proposed impervious? But what we're actually looking for here, which you should input or the applicant should input, is total proposed impervious. So we were adding 1.84 acres to that 0.28 acres. So it's a total of 2.12 for our total proposed impervious. Step 3, I'll talk about next, but that's where these numbers are being used to calculate what our 10% phosphorus reduction requirement is. I'm just going to skip to step 4 for now, since it's kind of on the same view here. But for step 4, all we're doing is kind of telling the spreadsheet what type of soil we're working with, because it changes how efficient practices are and which ones are most appropriate there. So again, this is entirely soil type C. So on the same page, but scooting over to step 3, you won't see any blue boxes because we don't have to do anything here, but it's taken our site area information, done the calculations for us, and it's saying our removal requirement is 2.94 pounds of phosphorus per year. All right, so just back to our site plan. The next sheet I wanted to point out is 2 of 10, if you're following along in there. This obviously looks very similar to our standard site plan, but this is our drainage areas for our individual stormwater management practices. So these are all kind of oddly shaped, and we're going to sort of isolate one practice and one drainage area at a time for now and go over that. So the one I've chosen to demonstrate right now is this one, MB7, which is just saying this is microbioretention number 7 on this site. So this drainage area is one of the larger ones out of all of them on here. That doesn't really matter, but I'm going to show you a chart in a second where you'll notice numerically that it is one of the larger ones. But I also wanted to point out before we get to that chart that most of this drainage area is impervious because it's in the forest conservation area. But we do have some, sorry, I should have said pervious. Most of it is pervious. Some of it is impervious, with a portion of a few of the townhouses in there, as well as a walkway through the forest conservation area. So not all of our, I should have mentioned this first, but obviously we're going to see plans that don't look like this. So you might have to dig a little bit to find this information, or ask the applicant specifically to provide it if it's not in there. But this particular plan that we were given not only had this drainage area map delineated like this, but then they had this handy and helpful chart saying for each of our microscale practices. So here's our MB7, the one that I mentioned before. Here's the drainage area for it specifically, and here's the impervious area within there. And the reason I wanted to point these out is because these are all input points for our microbioretention tab at the bottom of the 10% spreadsheet, which we'll take a look at in a second. So again, as we talked about, most of this is in the forest conservation area, which is why our impervious area is pretty low compared to our drainage area being over 19,000 square feet. Okay, so this is a cross section, a generic one of a microbioretention facility. So I just kind of wanted to point out some other design specs that we care about when we're reviewing these, and make sure that we have this information to input into the 10% spreadsheet. So microbioretention facilities, there's usually some sort of sloped area that leads down to this depression. And things I wanted to point out here include ponding depth. There's usually, like I said, there's some sort of depression here that's intended to fill with water. So our ponding depth here is a 1/2 foot, it says. Also, this is not shown on the diagram, but usually there'd be a variety of plantings through here. We also have media depth. So that is 2.5 feet of planting soil. The media itself can vary a little bit. Different stormwater management engineers might use different materials. That's fine. But we do need to know what the depth of that material is, regardless of what it is. Other things that we need to know for the bioretention facility is the surface area, which this hasn't given us an example. Actually, it has. The example here is 1,600 square feet. And again, this is a generic one. This is not specific to microbioretention number 7, but we're going to go over those numbers in a second. Some other things to point out here is that microbioretention facilities have some, I don't want to use the word structural exactly, but there's kind of more detail, more going on here than in just like a rain garden, which is our next example. But for example, we've got a 1 foot wide sand layer that surrounds our planting media. And we've also got these like pipe inlet kind of things, as well as some stone surrounding the practice. Okay, so jumping back into our 10% spreadsheet, I'm going to just briefly talk about the tabs that we have at the bottom. Site design is where we put in our generic information. Calculation summary, I'll go over shortly, but this is basically just kind of a checkpoint, and it'll confirm whether or not your practices meet the requirement. And then we have a bunch of practices at the bottom. They all have their own tab. They specify what kind of soil. So we're looking at microbioretention for CD soil because we're only working with C soils, but there's also a tab for AB soils. If you just downloaded the 10% spreadsheet yourself, you'll notice that our tabs are not in the same order. That's only because I dragged over all the applicable tabs for this project just so that it was easier for me to find and demonstrate. You feel free to do that as well if you're looking at a project, this one or a different one entirely. And that you kind of just want to make it easier to access them. Otherwise, you might end up scrolling a decent bit to find what you're looking for. That's a little bit besides the point. But what I wanted to point out here is we are in the microbioretention tab. There are a bunch of them on the site, and that's totally fine. We just input them all separately. Our sample one right now, again, is number 7. So I've pointed it out here. Our contributing drainage area is a little over 19,000 square feet. If you recall, it's mostly in the forest conservation area. So the impervious cover is pretty low compared to the other ones. It's only 16%. The other information that we gathered is that surface area is 420 square feet. Ponding depth is 1/2 foot and media depth is 4 feet. You'll note that there's a blue box here, meaning you could put information in here if it's applicable. Down gradient practice basically just implies that once the stormwater has been treated with this practice, it goes to another practice and is further treated. And that can increase the overall efficiency because it's essentially being double treated. That doesn't apply here, so all of these are blank. The reason I wanted to keep this area in this presentation is just to talk about phosphorus removal efficiency. So you'll notice that for each of these, it says well, you can't see that word there, but it says baseline phosphorus removal efficiency is 50% across the board. That's just kind of a general standard that if somebody put in some very generic ponding depths, which a 1/2 foot of ponding depth is very common. Something between like 2 and 4 is very common for media depth. If we just put in a very general one, we'd expect the phosphorus removal efficiency to be 50%. The next tab, or not tab, but column, is adjusted removal efficiency rate. And this is basically evaluating the specifications we put in for this individual practice and saying, is it more or less efficient than kind of your average practice would be? And in this case, it's 66%. So this is a more efficient one. The reasoning is probably just because, excuse me, the impervious cover is so low. That's my assumption. I'm also not a stormwater engineer, so I don't want to go too deeply into it. And again, this isn't something you really need to worry about because it's not a blue box. We're not doing anything with it. But if, for example, you're evaluating a project and it's not meeting the 10%, this might give you a little bit of insight as to why. So, for example, if we look at this one that stands out, in red as 33%. I didn't change this color. It did that automatically. So this one, the spreadsheet is identifying that this particular microbioretention facility is less efficient than we would expect it to be. Maybe that's because, in this case, the impervious surface cover is consistent with the other ones that are just fine. It's probably because its surface area is so small in comparison to the other ones. So just something to keep in mind if you're just trying to figure out why you're not getting as much out of a particular practice as you expected to. Okay, so back to our drainage area sitemap. We're going to go ahead and focus on a different drainage area and a different practice. So over here, this is RG3 or Rain Garden 3. You'll notice that the drainage area for it is very irregularly shaped, but it's also a lot smaller than when we were looking at this practice right here, MB7. So other things to note before we move on are that most of this is impervious. So we've got part of the road running through this drainage area, a portion of some of the houses, but we do have a strip of pervious area. So I think what the chart shows us is about 75% impervious. So we've got a drainage area of, I don't know, 6,500 square feet or so. I'll just simplify it that way. An impervious area of over 4,000 square feet. And again, that makes sense having looked at what was going on within that drainage area itself. Excuse me. So if you're taking a peek at the site plans, this is on sheet 6 of 10. This is a rain garden cross section. So again, this is, I think, similar in function to a microbioretention facility in that it has plantings. There's media depth and ponding depth, as well as this sloped area that's leading to a depression that's intended to fill with water. But it's a lot simpler. We don't have like a sand filter around the whole thing or some sort of stone structure higher above the practice itself. So specific parameters that we're looking for a rain garden include surface area, ponding depth, and media depth, or the difference between the bottom of this mulch layer and the bottom of the planting media itself. So because there are multiple rain gardens, so there are 3, they've kind of created this chart with each of these factors labeled with a letter. So in this case, we're looking at rain garden number 3, if you recall from the drainage area map. And we're most interested in the difference between C and D because that's our media depth, which here it goes from 14 to 15.25 feet in elevation. So that's 1.25 feet of media depth. And we're also interested in surface area, which this chart indicates. The surface area of this particular rain garden is 620 square feet. As far as ponding depth goes, I'm pretty sure it's just generic across the board for this particular project of a 1/2 foot, as indicated right here. So jumping back into our 10% spreadsheet, rain gardens with C&D soils have their own tab. Again, there were 3 of them. You'll notice there's a 4th line here, and that's just all of the rain garden plant. Excuse me. Rain garden planter boxes, they've kind of added all of them together. There's certainly not a single rain garden planter box that's almost 16,000 square feet. This is just a bunch of them. We're going to ignore that one for now and just focus on rain garden 3 because that's our sort of example that we're looking at. But if you recall, we had over 4,000 square feet of our contributing drainage area. A lot of it was impervious, so that percentage is 76%. And then from the chart that we just looked at that was provided by the applicant, the surface area was 620 square feet, ponding depth was a 1/2 foot, and media depth was 1.25. And like we talked about before with removal efficiency, the standard for a rain garden in C and D soils is about 25%. This one is slightly more efficient than you might expect it to be, so it's reaching an adjusted removal efficiency rate of 31%. So those are the practices I wanted to chat about for now. If you have questions about the other ones on site, we can certainly take a look at those tabs. And I'm going to pull up a live 10% spreadsheet in a second. But what I wanted to show you next was the calculation summary tab. This should be the second one if you've downloaded this spreadsheet. So what it does, again, there's nothing to input here, no blue boxes, but it kind of summarizes what we've looked at so far and tells you whether or not the requirement's been met. So our removal requirement from the very first step is 2.94 pounds of phosphorus per year. Our total load reduction after all of our practices have been put in here is 3.79 pounds of phosphorus per year. And this very last row under critical area 10% calculations is the important one for you to check like at a glance. Total load reduction remaining, it's 0, meaning we've met and in this case exceeded what our 10% requirement is. So we don't necessarily, well, we absolutely in this case don't need to add any more practices or tweak them to be more efficient. If this were anything other than 0, it would indicate that something either needs to be reevaluated, maybe for location, maybe for its design specs, or there just needs to be another practice added. So before we get into frequently asked questions, I'm going to go ahead and escape and go into our 10% spreadsheet real quick. And this is just to kind of reiterate what we've talked about so far. So again, I left these blank. Hopefully you can see this pretty well, but let me know if you want me to zoom in. I'll zoom in a little bit. I left these blank because it doesn't really affect the outcome of the spreadsheet. Again, we've put in step 2, our site area, existing, and total proposed impervious, which spit out over here in step 3 that we owe almost 3 pounds of phosphorus per year. And then we had our soil type input over here. So scrolling down, you're not going to see anything that you need to input again, but this is kind of a summary of all the practices for this particular project. And if you recall from the site plan, there's a whole bunch of them. And so it doesn't list them individually, but it does kind of accumulate them and tell us what the totals are. So we've got some non-structural practices here, disconnection of non-rooftop runoffs. It's telling us that total, the contributing drainage area was 1,000 square feet. And we don't need to go through all of these, but I just wanted to point out that if you were wondering what's going on down here, this is just a summary of all of the other tabs total. We've also got a total of over 13,000 square feet of contributing drainage area for all of those permeable pavers that we saw. We've also got a submerged gravel wetland somewhere, a bunch of rain gardens, and microbial facilities like we discussed. So moving on, the second tab is our calculation summary. This is the one we literally just went over. So again, we can see what our requirement is, what's been provided by the practices proposed, and then how much is remaining, which again, for this one is nothing. And then these are all the different practices that this particular project proposed: non-rooftop disconnects, again, permeable pavers, etc. I wanted to show you this one real quick, rooftop disconnect. There weren't any of these, there weren't any of these for this particular application, but we wanted to point it out because we talked about some Eastern versus Western Shore parameters for practices, and this one does have a tab, so you can input that information in there. Eastern Shore, Western Shore. I'm sure this looks very small on your screen right now. I'm sorry about that. But just know that that is in here, so it's factored in when it's applicable. So yeah, so these are all of the practices that we've covered. I'm going to go back into our presentation. So at this point, we're hoping that we answered a lot of frequently asked questions, such as rules for measuring impervious cover and how do permeable pavers and green roofs affect impervious cover. So at this point, we'd like to take any remaining questions you guys have. If there's something you want to look at again or in more detail, let us know and we're happy to dive into it. Otherwise, thank you for tuning in.
Awesome. Thank you, Alex. It doesn't look like we have any questions in the chat, but if anybody wants to unmute and ask a question, or feel free to type anything into the chat. It was a lot of information, I know.
Yes, I'm hoping that having been sent the examples, that gives you some guidance. And, if you ever have questions about completing one of these or having an applicant complete one of these spreadsheets, I'm happy to take questions and kind of walk through that with you. I'm sure some of our other planners are as well. Again, we're not stormwater engineers. There are some things that when I was pulling these slides together, I had to double check and question myself. So it's, totally fine and normal if that is the same situation for you. It's not always straightforward or intuitive, but there's usually a way to get the information that we need to complete this spreadsheet.
Yeah, and Alex is right. If you have questions about it, or if an applicant needs assistance with the 10% spreadsheet, definitely reach out to your Critical Area Commission planner contact, or myself or Nick. We'd be more than happy to help walk you through it. I guess if there aren't any questions, we can conclude the training. But we definitely appreciate everybody participating today and asking questions. It was great to have so much interaction and feedback from everybody. So we really appreciate it.
Thanks, everyone.
Yeah. Thank you all for being here.
All right. Awesome. Thank you, Aaron and Leah.